Hello everyone, this is Mr. Ayab. Right now, I'm gonna show you some question that is really hard in our worksheets. Now, why should I explain this to you? Because most of you have answered it, some of you have answered it, and then the answer, all of you, wrong. So I think I have to guide you through this video to answer the question. But then I will not give you the final answer, you have to find it by yourself. Then, after you get the answer, you can actually try again the worksheets. Answer it several times until you make sure your score is satisfied for you. Okay, now let's start. The first hard question is question number 6. Okay, let's see the question. The diagram shows an aircraft flying in a straight horizontal line at a constant speed. Okay, this is interesting. The keyword is actually constant speed. Constant speed means the speed doesn't change. So is there any acceleration? No. No acceleration. So we can say acceleration is 0. And then in this chapter, you have learned about the force. And what is the equation related to force and acceleration? Right, it's force equal to mass times acceleration. But then, if we have more than one force, you already know that we have resultant force. What is resultant force symbol? Sigma F. And then, you just submit the equation, m times a. Now, since acceleration is 0, you can submit into this so that resultant force is equal to 0. Now, what happened? Resultant force can be in two directions. Based on the diagram, we have those forces that are in the x-axis, which is horizontal, and the other one is in the vertical, which is y-axis. In the x-axis, you can see we have T and then D. Remember, T is to the right, so it's positive. D is to the left, so it is negative. In the vertical direction, we have L and W. L is upward, which is gonna be positive, and W is downward, which is gonna be negative. So, this resultant force, you can write it in resultant force in the x direction and resultant force in the y direction. Both of them will be 0 because the resultant force is 0. Then, if resultant force in the x-axis is 0, that means force in the right minus force in the left will be 0. Or force on the right will be equal to force on the left. The same with resultant force in the y-axis, equal to 0. So that means resultant force upward will be equal with the resultant force downward. Now, it's time for you. Analyze which one upward, downward, left and right, and get the answer. That is for the question number 6. Okay, now the second difficult question is number 7. Number 7 is actually related to the Hooke's law, because when you add weight, the extension also will increase. Now, what is the Hooke's law equation? Hooke's law equation is force equal to K times extension. And K is a spring constant. You can see the question is actually how you can get a spring constant. I said before, the spring constant can be got by finding the gradient, right? But be careful. At that time, the weight is in the y-axis and the extension in the x-axis. But right now, they are reversed. Then how you get it? So you can always start with the K. K based on that equation, it's gonna be F divided by the X. Which one is the F? the force. And based on the diagram, the force is the weight. This one. And which one is the extension? Of course, this one. So, what happened? This is if you have a single one. Single force, single extension. But if you have many, you can find the difference in the force divided difference in extension. Now, based on the diagram, you can see the difference in the F is actually this one. Because F is in the horizontal, so any change in horizontal, that is the delta F. So the P will be delta F. And what about the extension change? Is here in the y-axis. That's gonna be the Q, right? So what's gonna be the final answer? You decide by yourself. Number 12 is difficult too, but then let's see. Based on the description in the beginning of the question, the object moved from X to Y. So this is the direction, from this to this. Then actually if you make into the full circle, this is supposed to be like this. What is this one? This is actually clockwise direction. Okay. And then what happened? This is actually part of the circular motion. In the circular motion, there is actually one force. Sorry, not circulation, it's the circular motion. In the circular motion, there is a force that acts as the resultant force. What's that? The resultant force is actually the centripetal force. Centripetal force, what's the direction? To the center. Okay, but then what happens if, for example, that centripetal force is removed, which is that is part of the equation. So what happened? The object will not move in the circle. No. So imagine if the object is in the X position. This one will go to the right. And then if the object is on the y-axis, what happened? Not y-axis, sorry. How if the object is in the y? This is the y. So it's gonna be going downward. So right now, how if the object is at O? What's your answer? The next question is question 15. If you have this kind of question which contain many numbers, it's better to analyze each numbers. So like this one, this is actually mass because the unit is kilogram, and this one is the force, and this one is the time. Good. That's it. There is actually this condition to stop. To stop is actually the final condition, which is the final speed. What is final speed symbol? Is it U or V? It's V. So what is it? Stop means the V is 0. So what is this? In the beginning there's supposed to be a speed, right? And then at the end there is no speed, or the speed 0. So in here there is actually change of the speed, which is what? Acceleration. But since the speed decrease, it is deceleration. So what happened? We have the force, we have the mass, we have also acceleration. What equation you can use? It's F equal to m times a. So what is it? First of all, you can change this equation. What's that? While using the acceleration equation. What is acceleration equation? If you have final speed, initial speed, and the time, this one. Okay, now what is this? We will submit the A to that equation. So you can have F equal to M in the bracket V minus U over T like this. Or actually you can write it like this. V minus U divided by the time. Again, what should you find? Initial speed is U. Then you have to change this equation to find U. How? It's up to you. Okay, it's time for you to change it and then submit all the data to get the answer. Good luck. Okay, when you get this question, guys, it's actually weird. Why? The unloaded length of the spring is 18. This is L1. And then when there is a weight hung on it, what is it? It's become 16.6 centimeter. Is this logic? No. Because what happened? How can, when you add this load to the spring, it's decreased from 18 centimeter to 16.6 centimeter? It's not logic. So this one's supposed to be a wrong question because the data is wrong. But then, let's say I change it. Yeah, so this is revision. We just switch. This one, L1, 16.6 centimeter. And L2 is 18 centimeter. So, what should you do? Okay, you have to find extension first. How to find the extension? Always remember extension is final length minus initial. So, you can find it by yourself. After you got the extension, guys, find in this one what's the extension. Let's say, right, so it's not the real one. Your extension is actually 1. So, what should you do? You get 1 here, go to the right until you meet the line. Don't continue, because that means that's the limit. After that, what happened? You go down. There, you find the force. So if the extension is 1, the force is how many Newton? Correct, 2.5 Newton. But is it true? Not really, because you have to find the extension first. You can do it.